We're continuing to look at conic sections. We've looked at ellipses, we've looked at hyperbolas, and now we're going back to parabolas and looking at parabolas kind of written in a different form than we've seen in the past. In the past, we've looked at parabolas facing up and down, but now we're also going to look at parabolas that face left and right. So let's just look at the definition of a parabola really quickly. A parabola is a set of all points in the plane equidistant from a fixed line, which is called the directrix, and a fixed point, the focus. So basically what this is saying, let's see if I have a picture down here, that there is some point on our parabola, every point on our parabola, there's an equal distance down to this line, which is called our directrix, and this line that joins the point on the parabola and the focus. So just the same thing with ellipse and hyperbolas, knowing the definition in that way is not going to help us graph it. Knowing certain things about the graph is going to help us graph it. So there's two different forms that we can write our parabola in so that we can see which direction it's facing. If your x part is squared, just like before, y equals ax squared plus bx plus c, we knew it was a parabola that faced up or down. So if the x part is squared, it's going to go up or down. If your y part is squared and not the x, then it's going to either go left or right. If we can put it in this form where we have the perfect square, x minus h quantity squared is equal to 4p times y minus k. So in this form, our vertex is in the form of hk. So recall h is always the number that is with the x term, and k is always the number with a y term, and their opposite signs. Also, the value of p, this coefficient out here, if that is positive, then it tells us our parabola is facing upwards, if it's up, or it's facing towards the positive x direction, if it was our y part that's squared. Again, there's two things that are going to help us with these. It's our focus. Our parabola always faces towards the focus. So I'm putting the focus in all four of these parabola shapes. Our parabola shape always goes away from the line, which is called the directrix. So if it's facing up or down, the directrix is a horizontal line. If our parabola is going left or right, our directrix is going to be a vertical line. Okay, so from here, we can look at things. So let's talk about how you find that foci, or how you find the line for the directrix. So different books has different variables. Right now we're saying P, your book uses the variable A instead of P, but it's the same idea. So technically, if you know what the vertex is, which we can tell if it's in standard form, is HK. If I go up P units, that is going to get me my focus. So my focus in this case, I'm affecting the y value of my point. So my x value is going to stay the same. So it's going to be HK plus P. Where here, if I'm looking for the focus, I'm going to be going down p units. And so my focus in this case is going to be h, comma, k minus p. The directrix, this is the line. I'm going to go down p units. This is the y value going down p units from my vertex. So it's in the form y equals k minus p, or over here, the directrix is going to be above the focus. So the directrix is going to be y is equal to k plus p. If our parabola is going left or right, to get the directrix, we would be going to the left p units. And so that's affecting the x value of my vertex. And so this is going to be h minus p, and that's a vertical line, so it's going to be x equals. Or over here, the directrix, this is length is p. To get this vertical line here, it's going to be x is equal to h plus p. To get the get the foci though, adding p to our x value, this is going to be h plus p comma k for the vertex. Or this one right here is going to be h minus p comma k for the vertex. Okay, so now let's look at an example of parabolas and graphing.
Wouldn't we just distribute and
So the equation in front of us is y plus 2 quantity squared equals -4 times x minus 2. So it's in that standard form that we had just seen. I look to see which part is squared. It's the y that's squared. So that tells me my parabola is either going to be going to the left or to the right. This value right here, this is in the form of 4p. I have 4p is -4. And so if I solve for p in this case, I get p is -1. So since this is less than 0, this tells me my parabola is actually facing towards the negative x direction. In here, we can tell what the vertex is. The vertex is hk. Our h value, though, is always with our x, opposite sign. So it's going to be 2. Opposite sign here, so this is going to be -1. So I know to get to my focus, which my parabola is always facing towards. So we saw that our p-value is -1. If we look at our focus is going to affect our x value of our point, and we're going to subtract 1 from that value. And so my focus then, subtracting 1 from my x value, not my y value. That's my problem. So I'd have 2 minus 1, which is 1, -1. Where my directrix, my parabola is always going away from this. This is in the form x equals. Well, my x value of this point was 2. And then I'm going to go over 1 to the right, so +1. So my directrix is x equals 3. So let's put what we have so far. We had a vertex, which was at 2, -1. We have a focus, which is at 1, -1. And we have a directrix, which is at x equals 3. So it's always going to be going towards the focus, away from the directrix. So there's a couple things that we can do to kind of figure out how wide this is going to be. We can figure out what our x-intercept is and what our y-intercepts in this case are. So if I was to look at my x-intercept, this is when y is 0. And so doing that, I get 0 plus 1 squared. So I get 1 squared is equal to -4 times x minus 2. So I have 1 is equal to -4x plus 8. Let's subtract 8 on both sides. I get -7 equals -4x. And so x is equal to 7/4. So that's about 1 and that is 1 3/4. So that's about right here. This is going to be symmetrical. So if I went over here, 1 3/4, down 1. And then let's find our y-intercepts. This is when x equals 0. So if we let x equal 0, we have y plus 1 quantity squared equals -4 times 0 minus 2. So times -2. So we have y plus 1 quantity squared equals 8. So notice we can use our square root method that we learned at the beginning of the semester. We could take the square root of both sides. So we get y plus 1 equals plus or minus the square root of 8. So subtract 1 on both sides, I get -1 plus or minus 2√2. So graphing that doesn't make much sense to me. So let me put that into the calculator and get an estimate. So plugging that in the calculator, I get y is approximately 1.8. About here, and 3.8. About here. So we get a shape, or we get a graph of our parabola by finding the directrix, the focus, the vertex, and our intercepts. So from here, you should be able to tell me what the range is. So you should be able to tell me what the domain is. For us, the domain, we're hitting all of our x values from -infinity until this x value of 2 including. Our range, though, we're hitting all of our y values. So our range in this case is -infinity to infinity. So let's look at a case where we have to put it into that standard form to answer the questions. So our next example is y squared plus 12y equals -x plus 1. So by just looking at the equation where it's not in standard form, I can tell that this is going to be a parabola shape because I don't have both x squared and y squared. I know that the parabola shape is either going left or right because my y value is squared and not my x value that's squared. So I want to put it in the form where I have y minus k quantity squared is equal to some constant 4p all times x minus h. So I want to complete the square on my y terms. And so I need to figure out what value I'm going to add on the left-hand side to make this a perfect square. Well, half of 12 is 6, so 6 plus 6 is 12, and the number we're adding is 6 times 6, which is 36. If I add it on one side of the equation, then I have to add it on to the other side of the equation to make this equivalent. So I'm going to add 36 to the other side also. This one side now is a perfect square. We can rewrite y plus 12y plus 36 as y plus 6 quantity squared equals negative x plus 37. In this form, notice that coefficient in front of the x inside that parentheses is 1. So we want to factor out whatever number is in front of x out of both of those terms here. So I want to pull a negative 1 out of that, which would give me x minus 37 on the right-hand side. And this is still equal to y plus 6 quantity squared. So now it's in the form where I can find the vertex. So my h value opposite sign is 37, and my k value opposite sign is negative 6. I need to figure out what p is. So I know that 4p equals the coefficient that I have outside of this parentheses, which in our case is negative 1. So I know that p here is negative 1/4. Since that number is less than 0, we are going to have our parabola face to the left. So I am going to subtract negative 1/4 from my x value to get this focus. So I would have 37 minus 1/4, comma, negative 6. So this is 36 3/4, negative 6. My directrix is a vertical line. So my directrix is in the form x equals, and so from my x value of my vertex, 37, I'm going to add 1/4. So another way to write this is 37 1/4. So from here, we want to graph this. So yep. So graphing this, x is 37, so that's really large. And y is negative 6. I'm just going to say this is 37. Let's say that this is negative 6. It's not to scale. We have something right here, and we know we're going to go this way. It will be helpful if we can find our x and our y intercepts to help us graph and see how wide that parabola shape is. So if I wanted to find my x-intercept, that's what y equals 0. So I'm going to plug it back into this equation right here. So if I let y equals 0, I get 6 squared, which is 36, is equal to negative x plus 37. So if I subtract 37 on both sides of my equation, I get negative 1 equals negative x. And so x is equal to 1. So it's going to be crossing right over here.
How detailed do you want us to be on these graphs during an exam?
It doesn't have to be too detailed, and it won't be as huge numbers like that. A y-intercept, that's a little harder in this case, but not too bad. It's in a form where we can use the square root method. So let x equals 0, we get y plus 6 quantity squared equals equals positive 37. So take the square root of both sides, I get y plus 6 equals plus or minus the square root of 37. Subtract 6, I get y equals negative 6 plus or minus the square root of 37. Well, square root of 37 is just a little bit above 6. So if I add a little bit more than 6 to negative 6, I'm just going to be above the x-axis just a little bit. So something that looks similar to this. And you can plug that in the calculator and you can get an estimate to graph it if you need to. So now we're given information about our parabola and we want to find the equation for that parabola that has this information. We're given that the focus is negative 4, 4, and the directrix is y equals negative 2. So just like with our ellipses and hyperbolas, it's important to kind of graph what you're given so you can kind of determine which shape am I dealing with. In this case, we want to know, is our parabola facing up, down, left, or right? And that's going to give us the general form of that equation. So if I plot the focus, which is at negative 4, 4, so the left 4, up 4, that's my focus. And my line is y equals negative 2. Well, I know y equals negative 2 is a horizontal line. So I have my directrix here, y equals negative 2. So since I know that my parabola is always facing towards the focus away from the directrix, I can tell that my parabola is going to have to be facing upwards. So I know that the standard form when it's going upwards is x minus h quantity squared is equal to 4p times y minus k. So I know that my x value of my vertex has to be lined up with this focus. So my x value of this focus, h, is negative 4. I know that the y value of my focus, or my vertex, the y value of my vertex is halfway between this point and this point on y equals negative 2. So I have a y value from negative 2 to 4. So that length is 6. So I know half of the length of 6 is 3. So I'll be going down 3 or from my focus, or up 3 from that directrix. So from here, I can tell that my vertex is at the point negative 4, 1. So my k value in here is 1. So far, we have x minus negative 4, so x plus 4 quantity squared equals 4p all times y minus k, so y minus 1. So I know that this distance in here, I would go up 3 and down 3. So I know that p is equal to 3. So now I have my equation and I know it's positive because I'm facing upwards. This value has to be greater than 0. And so now we have the equation x plus 4 quantity squared is equal to 4 times 3, which is 12, all times y minus 1. And so here is our equation of our parabola given the information about the graph. So now in front of us, we have 10 different equations. They're all conic sections. So they're going to be either a parabola, circle, an ellipse, or a hyperbola. from just looking at the equation, you should be able to tell me what type of shape you have. And from there, you should be able to put it into the standard form where we can find the important informations like vertices and centers, foci, focus, whatever it is based off of that conic section. And so looking at this, let me know if you have any questions on what these shapes are, and then we'll talk about it. So we discussed there's a way to look at the equation and tell if it is a circle. A circle is going to have an x squared and a y squared, and they both have the exact same number. So looking at these, I don't think I see any circles in here. If it's an ellipse, we have an x squared and a y squared value, and both of the coefficients in front of x squared and y squared are the same sign. And so looking at this, if I look at that, I notice that number 3, this would have to be an ellipse. X squared and y squared, and they are the same sign. So number 8 is going to be an ellipse. And number 10, these are all ellipses. I know parabolas just either have a y squared or an x squared. So if I look at one, that just has a y squared. So one would be a parabola. Maybe we could do a different color. So one is a parabola. 4 is a parabola. I can see that 6 is going to be a parabola. And it looks like 9 is also a parabola. Hyperbolas, we both have an x and a y squared in the equation, but we have opposite signs in front of the x squared and y squared. So notice number 2 has an x squared and y squared, but one's positive, one's negative. So I can see 2 is a hyperbola. Opposite signs, one's positive, one's negative, so 5 is a hyperbola. 7 opposite signs is a hyperbola. So just by looking at the equation, I could identify the shapes of each one. You should also be able to go and again, put that in standard form, find your important information and graph it. So looking at number 2, we have x squared all divided by 25 minus y squared equals 1. So this is already in standard form. I notice that my center, my HK, there's no x minus h quantity squared, it's just x squared. So my h value is 0. Same thing, this is y minus k quantity squared, so my y value of my center is 0. We look at, is it the x squared term, that piece, is that positive or negative? The one that's positive is telling me which direction the hyperbola shape is facing. And since the x is positive, I know it's going towards the positive and negative x direction. So my hyperbola is going to be like this shape. I know the value underneath the x squared. My value there, a squared, is 25. So I know a is 5. B squared is 1. And so B is 1. So from my center, I'm going to plot points. So let's see, my center is 0, 0. I'm going to go to the right 5 from my center. Gives me a point. I'm going to go to the right and left 5. And this gives me a point. I'm going to go up and down 1, my B value from my center. And then I can form my rectangle with these points. From here, I can get what my asymptotes look like. And so they're going to be the vertical lines going through the corners of the rectangle that passes through the center. So from here, this point is going to give me my vertice, and my parabola shape is going to look like, parabola shapes of the hyperbola kind of look like this. So I have my vertices on the transverse axis. These points right here, well, left 5, so that's going to give me -5, 0. And to the right 5, it gives me 5, 0. The vertices on my conjugate axis, it doesn't help me, I mean, it helps me graph it to know what the shape is. But the conjugate axis, it would be 0, 1, and 0, -1.